Now let's consider common logarithms. And a common log is really nothing more than log base 10. That's what is called the common log. And we can use it to evaluate the basic properties of logarithms. So if I've got log of 1, log base 10 of 1, well, that's going to equal 0. And if I've got log of 10, log base 10 of 10, well, that equals 1. That's like 10 to the first power, if you will. The log of 10, the common log of 10 raised to the power of x is equal to x. And 10 raised to the power of the log of x is going to equal x as long as x is greater than 0. Basic properties of common logarithms. And so we're going to evaluate 4 of these. One of these, this one here, I'm going to actually use the calculator on because I don't know that I can do that in my head. In fact, I can tell you I can't. So let's see. If I'm looking at the log base 10 or common log of 10,000, so I'm thinking, okay, what power does 10 have to be raised to equal 10,000? Well, let's see, 10 squared is 100, so that'd be 2 is 100. 10 cubed, 10 times 10 times 10 is 1,000. And so if I evaluated that, that'd be 3. And so let's see, 10 to the 4th power, 10 times 10 is 100, times 10 is 1,000, times 10 is 10,000. And so the log of 10,000, evaluating that, is just simply going to be 4. Now, like I said, this common log of 0.081, I'm going to jump over to the calculator and do that. How about the log of negative 0? The common log of negative 0. Well, I don't even know what negative 0 is. I mean, 0 is neutral, right? And I think we just said that the log, what do we say about something about greater than 0? Yeah, 10 raised to the power of 0, to the log of x, I mean. So anyway, well, there is no such thing as negative 0. So this is no real solution. All right, and then how about 10 raised to the power of the common log of 3? Well, 10 and the common log are going to cancel. And so we're just left with this is going to equal 3. But remember, if I've got 10 raised to the power of the log of x, x being 3 in this case, it's equal to x as long as x is greater than or equal to 0. Which, by the way, you can't take the log of a negative number. The log of something could equal a negative number, as we're about to see, but you can't take the log of a negative number. So let's move over here to the calculator and let's evaluate the expression, the log of 0.081. All right, well, here we are over on the calculator, and we're going to evaluate the log of 0.081. And so I'm just going to hit the log button, which is just to the left of the number 7. So I hit log, it's going to give me a parentheses, and then I'm going to put 0.081. Close my parentheses, hit the enter button, and shazam, that's equal to negative 1.09, rounded to there. Let's just go with negative 1.09. Now I'm just kind of curious, what if I took 10 and raised it to the power of negative 1.09, just for fun? Well, I can do that if I hit second and the log button. If you look there in blue, that means it's 10 raised to the power of x. And so I'm going to take my previous answer, so I'm going to hit second answer. That's going to load in that negative 1.09, and I'm going to hit enter. So what is 10 raised to the power of negative 1.09? See, I know that negative puts that in the denominator, doesn't it? I bet it's going to be something less than 1. And in fact, it is 0.081. Once again, kind of proving that logs and exponentials are in fact the inverses of each other, which is an important thing to know.